So first off, it tells us that we are given f of x. So this is the function f of x. And it's 4 line segments. It's a quarter circle, and then y equals x squared from -1 to 1. Okay? And then we've got that g of x is the integral from -1 to x of f. So starting at -1 and going this way, or potentially going to the left, we need to find a value like -4. So first off, to find g of -4, we just plug in -4 for x in our function g. So that's the integral from -1 to -4 of f of t dt. And then since this is having us do an integral from -1 to -4, and that would be moving to the left instead of moving to the right, we want to flip the limits of integration and make it negative. So we're going to take the opposite of the integral from -4 to -1 of f of t dt. Everybody good with that so far? Yeah. So then we'll integrate from -4 to -1 with a negative out in front. So negative. And then the integral from -4 to -2 is just this line segment. That's a triangle, 1/2 of the base, which is 2, and the height, which is 1. Some people didn't really look at the scale on this and messed that up. Right, that's saying there's little four boxes there, but that's just 2 units, and 2 boxes is 1 unit based on the scale. And then we got to add in this piece that is the quarter circle here. So a quarter circle should have an area of 1/4 pi times the radius squared. And if that's a quarter of a circle, then the full circle would look sort of like that if I drew it better. It's got a radius of 1. So 1/4 of pi times 1 squared. Distribute your negative through, and you got -1 minus pi over 4. Everybody good with the first part of part A? Good? Austin, good? Andrew, good? People in the Zoom, you good?
Yeah.
Good. All right, g of 2 means the integral from -1 to 2 of f of t dt. And the integral from -1 to 2, well, that's got this parabola from -1 to 1. So that's just the integral of x squared from -1 to 1. And then plus this area that we get underneath the curve from 1 to 2, which is just a square. So 1 unit by 1 unit is 1. That's our integral from 1 to 2 of f of t. And so we integrate x squared to get x cubed over 3 from -1 to 1 plus 1, which is 1/3 minus -1/3 plus 1. Which is 5/3. I split it into 2 integrals, one from -1 to 1 because that's the parabola. And then the 1 is from 1 to 2. It's just the square. It's a 1 by 1 square. So it's an integral from -1 to 1, and then it's an integral from 1 to 2 because there's different functions that define the top of that region. So you have to split it at the place where it changes functions. Does that make sense to everyone? Yeah. Okay. Part B. Does G have any points of inflection on the open interval -4 to 6? So points of inflection should occur when G double prime changes signs. And G double prime is equal to what? G prime is just F, so G double prime is F prime. So we're looking for when does F prime change signs? Well, F prime is the slope of F. So here, F prime is less than 0 because the slope here is negative. And here, F prime is greater than 0. And here, F prime is less than 0. And here, F prime is greater than 0. And here, F prime is 0. And here f prime is less than 0, and here f prime is greater than 0. So where did it change signs? Well, it changed signs at -2. It changed signs at -1. It changed signs at 0. It went from positive to 0 at 1. That's not a sign change. Right? It went from 0 to negative. That's also not a sign change. Okay? And then it switched from negative to positive at 4. So it has 4 points of inflection. -2, -1, 0, and 4. It has to go from positive to negative. It did not do that at +1 or at 2 because it just had a slope of 0. Everybody good with that? Okay. For part C, to find the maxims and mins, that means that G prime, which is F, changes signs. And note, some people put endpoints also, which would be good if this was a closed interval, but this is an open interval, so you should not be including the endpoints on that. And if it was a closed interval, then sure, look at the endpoints and figure out if they're local maxes or local mins. But in this case, it's an open interval, so you don't have to worry about that. So now we just care about when does F change signs. Well, F is positive, F is positive, F is positive, F is positive, F is positive. F becomes negative at x equals 3. And again, it switches from negative to positive at 4.5. And we would say that at x equals 3, since the derivative of g, f, went from positive to negative, the function itself went from increasing to decreasing. So x equals 3 is a max, and x equals 4.5, where the derivative goes from negative to positive, should be a min. That makes sense to everybody? Serena, you good with that? Awesome. Good. Andrew, good. I think I'll check with the people that are taking the AP test. So, people in the Zoom, you good with that?
Yes.
Oh, wonderful. All right. And then part D says to find the absolute maximum of G on the interval -4 to 6. Well, an absolute max can occur at an endpoint or anywhere where we have a local max. So it might occur at -4, it might occur at 6, and it might occur at 3. So for part D, we need to check x equals -4. Well, we just need to find out, right? We should find G of -4. It was -4, right? Was the endpoint? We need to find G of 3, and we need to find G of 6. And we need to figure out which of them is the largest. G of -4, we already found, I think, in part A. Didn't we? What was G of -4? It was -1 minus pi over 4, I believe. Okay. That was probably not going to be the max. It's a negative number. Could be, but probably not. Actually, we should be guaranteed that it's not, because we know that G of -1 is, what's G of -1? Just by looking at the thing right here. If I put in -1, what do I get? 0. So the max is going to have to be something that's positive, right? So we know that it's not going to be at -4. So G of 3 should be equal to G of 2 plus this triangle. Right? What was G of 2? 5/3 plus this little triangle here. What's this little triangle? It's 1/2 the base times the height. So 1/2 of 1 times 1. So we have 5/3 plus 1/2. What's 5/3 plus 1/2? Should be 13/6, I believe. Yeah. And then to find G of 6, well, G of 6 is just G of 3 plus whatever we get between 3 and 6. So we'll start with 13/6. to get g of 6, we got to take this piece that's below that's negative. So we're going to subtract 1/2 the base times the height. And if you look at the triangle, the base is 1.5 or 3/2, and the height is 1. And then we've got to add the other piece, which is another triangle, 1/2 base times height. The base here is also 3/2, and the height is 3. So we've got 13/6 minus 3/4 plus 9/4. And what is that? That's 13/6 plus 6/4, or plus 3/2, which ought to be 9/6, so 22/6. 22/6 is 11/3. And 11/3 is certainly more than 13/6, and it's certainly more than -1 minus pi over 4. Any questions or issues with that one? Going good? So you good with that now? All right. I expect anybody that didn't get at least an 80% on that quiz to could just take a picture and resubmit it. Now that we just did it all, it should be easy. Lucky you. Yeah. Yeah. All right. Cool. How did the ones from yesterday go? They go all right or no? They were okay. All right, let's, just for fun, you should score yourself and see how many points you got. That'd be exciting. It'll either be really uplifting for you for June 9th or really sad and depressing. One of the two. Maybe it's in the middle. Who knows? Anyway, we want to find the average rate of change of f on this interval from -3 to 4. So how do we find an average rate of change? That's just the slope between any 2 points. So that's the point of -3 and the point of 4. So we'll find f of 4 minus f of -3 over 4 minus -3. What's f of 4? F of 4 ought to be, this is the cosine of 2 pi. What's the cosine of 2 pi? 1. So we have -4 plus 3 times 1. So -4 plus 3 should be -1. And then what's f of -3? Well, that should be -3 squared is 9. 9 minus 9 is 0. Should be 0. So we get -1 minus 0 over 7. -1/7. Good or no? That part A would have just been worth 1 point. So if you got that right, got an answer with a little work there, that's worth a point. All right, we're going to write an equation for the line tangent to f at x equals 3. So first off, we need to find f of 3. So we have the point. What's f of 3? It's -3. We're choosing the bottom one, right? Because that's 0 to 4. -3 plus 3 cosine 3 pi over 2. What's cosine of 3 pi over 2? What's the cosine of 3 pi over 2? 0. So we have -3 plus 0, which is -3. So first off, we're looking at the point 3, -3. Then we need to find the slope of this function, which means we need to find its derivative. So what's the derivative of -x? We'll say on 0 to 4. F prime of x is what? -x becomes -1, and 3 cosine pi x over 2 ought to become minus what? 3 pi over 2 sine pi x over 2. Everybody agree with that? I hope. Okay. Now we'll evaluate that at, what was it, x equals 3? So that should be -1 minus 3 pi over 2 times the sine of 3 pi over 2. What's the sine of 3 pi over 2? Should be -1. So that becomes the slope is a positive 3 pi over 2 minus a 1. So the equation of this tangent line ought to be y minus -3 or y plus 3 equals 3 pi over 2 minus 1 times x minus 3. And they gave you 2 points for that. 1 point if you got the slope, and 1 point if you correctly wrote the equation. Everybody good with that one? How are you checking your work if you don't have your paper out? You didn't do it. Oh, you weren't here. Right. You could be writing it down. Okay. All right, part C, we want to find the average value of f from -3 to 4. So how do we find the average value of a function on an interval? It's 1 over b minus a times the integral from a to b of that function. Well, we have an issue with the integral from -3 to 4 of that function. What's that issue? It's defined by 2 different pieces on that interval. That's okay. We'll just split it at that point. So 1/7, and then we're going to have an integral from -3 to, I think it was 0 is where the split was. Is that right? Was it split at 0? Let's look. Yeah, the split was at 0. Okay. So -3 to 0 of the square root of 9 minus x squared. Is that what the function was? I think that's what the function was. Yeah. Yeah. Okay. And then plus the integral from 0 to 4. What was the other one? -x plus 3 cosine pi x over 2. Everybody good with that so far? And then we have 1/7. Now, what's the integral from -3 to 0 of root 9 minus x squared? Anybody have a good way to integrate that? No. Can't do a u sub. You need to have another x outside of that somewhere to do a u sub. And there is a way to do that integral. It's a Calc 2 thing to like actually figure out how to do that integral by hand without thinking about what does this look like. What does the square root of 9 minus x squared look like? What does the square root of 9 minus x squared look like? We've talked about this many times. The square root of something squared minus x squared is a semicircle. But yes, this is a semicircle with a radius of 3. So this is the point -3, 0. So if we're talking about the integral from -3 to 0 of root 9 minus x squared, all that's really asking us for is the area of a quarter of a circle that has a radius of 3. So what's the area of a quarter of a circle? Well, it's 1/4 pi times that radius squared, isn't it? So that's all you got to do to find that integral, to find the value of that integral. And then we'll add to that the integral from 0 to 4 of this. So what is negative x becomes negative x squared over 2. And then to integrate 3 cosine pi x over 2. How are we going to do that? Going to need to use a u substitution. We're going to put in a, if u is going to be pi x over 2, we'll have to put in a pi over 2 here. And then we'll have to put in a 2 over pi here. And then we can do the u substitution. So this will become 1/7 of 9 pi over 4 plus negative x squared over 2. And then we'll have plus 2 over pi. And then if we do this integral, this just becomes 3 cosine u, right? And we're going to integrate 3 cosine u. That should become 3 sine u. So I'll put the 3 here. And it should be sine of u. Well, u was pi x over 2. And we still have to take this and evaluate it all from 0 to 4. Which gives us 1/7 of 9 pi over 4 plus, we plug in our 4, we're going to get negative 8 there. We're going to get plus 6 over pi times the sine of 2 pi. Minus, if I plug in 0 to all of that, what does it all become? 0 plus 0. So it looks like we just end up with all of the sine of 2 pi, like we said, is 0. So that goes away, that goes away. We've got 9 pi over 4 minus 8, all times 1/7, which was worth 4 points. That was probably the most difficult part of that problem, I would say. They gave you a point for splitting it into 2 integrals like this. They gave you a point for getting the value of the integral from -3 to 0 of root 9 minus x squared. They gave you 1 point if you correctly integrated the other part of it. And then they gave you 1 point for the final answer. Good or no? Yeah, that's fine. That's, in fact, that's how they have it written, I think. They have the 1/7 on the other side. So, yeah. Any questions at home on that one or here in the class? Everybody good?
I have a question.
Okay.
I have a question.
Yeah.
So for the test next week, if you're taking it online, how would they expect you, since you don't have to show like all this work, you just like type the answer in a box, how do you think they would like weigh the points out differently if you weren't like told to show all that work?
Well, I'm not going to ask you to show all that work. What they would want you to do is they would say that they'd probably break it down into multiple parts and be like, all right, well, they'd probably say just explain your process for doing this. So you'd say, okay, well, I need to find the average value. So I'm going to use the mean value theorem for integrals. And you put in whatever, you'd probably type in this. And then, they'd want you to explain how to evaluate that. So you'd have to just explain in words. You'd say, well, because this is a piecewise defined function, I have to integrate from -3 to 0 of the top piece and then 0 to 4 of the other piece. And then, you just can, you'd sort of just explain in words, I think, is what they'd want you to do. You'd say, well, the root 9 minus x squared is just a semicircle. So this is the quarter of a circle. So that's how we find that area. And then you'd say you have to do a u substitution to find the other one. And that'd probably be all they'd ask you to do, is my best guess. But they haven't released any specific digital questions for the calc test. And they said they weren't going to. So that's my bet. But it's, we've never had a digital test that was the full length format. So it's hard for me to say. Last year the digital test was just like the regular test. You just had to take a picture of your work and submit it. So this year it's different. So I don't, they haven't given us good direction, in my opinion. Sorry, that's not a great answer, but that's the best I got.
All right, okay, thank you.
Part D says, must there be a value of x at which f of x attains an absolute maximum on the closed interval -3 to 4? Well, that's the extreme value theorem, right? So for part D, the extreme what? Oh, hold on 1 second. What was that? It was a what? Quizlet? Is that like a little quiz? Quizlet? What an age we live in. Online flashcards that will talk to you. Sophie just had her laptop start talking to us about physio here in the classroom. I don't know. What was the flashcard about? What did you learn? Cool. Kidneys. Yeah. Renal. I got that. Kidneys. No way he's just learning A-B Quizlet. I've been using that for like 6 years. There's a Quizlet for calculus A-B? No, there's no learning about. A-B means about. You could just type the whole word out. But A-B means calculus A-B. Children these days, I don't understand. Quizlet? Quizlet. It just sounds like a little quiz. Like a little Quizlet. Oh, how cute. Look at this little Quizlet. It saved you? Habit. 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 Okay. All right. So the extreme value theorem. Right. The extreme value theorem is what guarantees that if you have a continuous function on a closed interval, there must be an absolute maximum. So we need to determine, is f continuous? That's our question, right? Because if f is continuous, the extreme value theorem will guarantee an absolute max on that interval. If f is not continuous, it's not guaranteed. So we go back and we're like, well, we know that f is continuous from -3 to 0, right? Because this is the semicircle. We drew a picture of it earlier. It's definitely defined for -3 to 0. And this is just an x with a cosine. Cosine is defined for all real x. So is x. So this is defined for 0 to 4. The question is, does the limit as we approach 0 from the left equal the limit as we approach 0 from the right? If that's true, then that means that the function is continuous at x equals 0. So we're going to say, is the f continuous? Yes, except maybe at x equals 0. And so for the function to be continuous at a point at 0, f of 0 must exist. Does f of 0 exist? Yep, I can plug 0 into that, right? F of 0 exists. True? Check. Okay. The limit as x approaches 0 must exist. And in fact, we're going to say that this equals, what is this? What does f of 0 equal? 9 minus 0 square rooted 3, right? Okay. Does the limit as x approaches 0 exist? So that's where we have to check the limit as x approaches 0 from the right of f of x. And does that equal the limit as x approaches 0 from the left of f of x? So from the left-hand side, we just did that. Right? From the left-hand side, we're using this function as x approaches 0 from the left. Our function is approaching 3. So 3, that's from the left, needs to equal the limit from the right. Well, to figure out the limit from the right, we just need to plug in 0. So we end up with 0 plus 3 cosine of 0, which is 3. So 3 equals 3. Yes, that limit exists. So if the limit as x approaches 0 exists and f of 0 exists, and they're equal to each other, they're both equal to 3, then yes, by the extreme value theorem, because f is continuous on that interval. And they gave you 2 points for that. 1 point for using the definition of continuity to prove that the function was continuous at 0, and 1 for an explanation. It doesn't specifically say that it has to include the extreme value theorem, but I think that it needs to say that theorem. So is that one good or no? Not good? Good? Bad? Got all 9 points? Got all the points for A, B, and D? Hopefully. And then like maybe some of the points in part C. That'd be. I would expect everybody to at least be able to get A, B, and D, and then like some points from C. And C you might have struggled with, but all right, we're all good? Everyone's good? Okay, let's look at the next one. Oh, it's another graph one. That's just like our quiz. That's fun. We just did one like this. So first off, I should probably read all of this junk. Horizontal tangent lines at -1/2, and 5/2. So those are mins and maxes. It tells us what f of x is from 1 to 4. It tells us the areas of A and B. That's 3 and that's 5. And g is defined by g of x equals the integral from -4 to x of f of t. So we want to find g of 0. G of 0 ought to be the integral from -4 to 0 of f of t dt. What's that? Oh, of f of t, yes. So that is just this triangular piece, which is above the x-axis, 1/2 times the base of 3 times the height of 3 also, yeah. And then minus this piece that's below, which is 3. So we've got 1/2 of 9, so 9/2 minus 3. 9/2 minus 3 is 3/2. Then to find g of 4, g of 4 ought to be, well, the value at 0, 3/2, plus the value from 0 to 1, which is 5, and then plus the integral from 1 to 4 of -x² plus 5x minus 4. And that's the function that we have from 1 to 4. Everybody good with that? And then we'll evaluate that out. So it's 3/2 plus 5 should be 13/2. So 13/2 plus -x³ over 3 plus 5/2 x² minus 4x from 1 to 4. Nice that they made you do such fun arithmetic, huh? 13/2 plus, that's -64 plus, what is that? Is that 5? Yeah, that's a 5. Can't read my own handwriting. 5/2 x². So that's 16, which is, divide that by 2, 8 times the 5 is 40. Minus 16. And then minus a -1/3 plus 5/2 minus 4. I don't know. What is that? What did that all come out to be? That's -63/3, which should be -21. So we got 13/2 minus 21 plus 40 minus 16 ought to be plus 24. We got a minus a -4, so plus another 4, and then we got a minus 5/2. 13/2 minus 5/2 ought to be 8/2. So we should have 4 plus 4 plus 24, which is 32, minus the 21. Looks like it should be 11. Hopefully I did all that arithmetic right. Let's see what the, oh, good. The scoring guideline says I did do the arithmetic right. Wow, that was worth 4 points. 1 point for getting g of 0. 1 point for splitting it up like this. 1 point for the correct antiderivative, and 1 point for the final answer for g of 4. So 1 point for g of 0 and 3 points for all that stuff in g of 4. Good or no? Yeah? Oh, good. All right, part B, find the absolute minimum of g on the interval -4 to 4. So first off, to find the absolute minimum, it could be at either of the endpoints, or it could be anywhere where the derivative, which is f, goes from, we're looking for a minimum, the derivative needs to go from negative to positive. So here my derivative goes from positive to negative. So that's a local max, so we're not going to worry about that. The local min occurs at 0, right? That's our local min. So g of 0. And we've already found most of these, right? What was g of 0? Oh, no, g of -4 we can find easily. I don't remember what we already found. Oh, we did find g of 0. G of 0 was 3/2, and g of 4 was 11. And what about g of -4? What's g of -4? That's the integral from -4 to -4, which is 0. So what did it ask for? The absolute minimum, right? Absolute minimum is 0 at g of -4. And that was worth, wow, 3 points. We should note that they gave a point for you noting that g prime was f of x. So 1 point for noting that. 1 point for identifying -4 and 0 as possible candidates. You didn't have to identify 4. We should note that it could have been because it was an endpoint, but you didn't have to because g of 0 was already less than that. And then 1 point for the final answer. So 3 points for that. Good? All right, and then part C, find all intervals on which G is concave down. Well, G double prime is F prime. We want it to be concave down, so we need that to be less than 0. So we're looking for when are the slopes of F less than 0? When are the slopes of F negative? Well, here's F. The slope of F is positive from -4 to -2. The slope of F is negative from -2 down to, what is that? -0.5 is what they told us. So -2 to -0.5. And then again, let's see, positive, 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 positive. Again, negative starting at +0.5. So from 0.5 to 1. And then again from, what was that one? 5/2 to 4. So 3 different intervals there. And they gave you 2 points. 1 point for the analysis that G double prime is F prime and it needs to be less than 0, and 1 point for the intervals on which that's. Good or no? Yeah. All right. I would be not surprised to see something like part C on the digital test, because that one just requires explanation, especially. So I would be surprised if you didn't see something like that on the test. Any other questions on that last one? Good.
I have a question about B.
About B, okay.
So do you not have to find like G of -1 and G of 1?
You do not. So G of -1, remember that G prime is F. So if G prime, we need G prime to go from negative to positive to find a minimum.
Oh, okay.
And here G prime is going from positive to negative. So this is a local max. And then here it's going from positive to still positive. So actually at 1, there's neither a max or a min there. Only when it goes from negative to positive is all we're interested in, and then the inputs. Does that make sense?
Okay.
Cool. All right. Brandon and Chloe are riding their bikes. Isn't that fun? All right. So we are given a chart with Brandon's velocity, and we are given a piecewise defined function with Chloe's velocity. We want to know how many miles did Chloe travel from t equals 0 to t equals 2. So normally, if we're going to do how many miles did somebody travel, we do the integral of the speed, right? Rather than the integral of velocity, because the integral of speed gives us total distance traveled, whereas integral of velocity gives displacement. But here, the value of the function from 0 to 2, right? If t is between 0 and 2, well, you know that t is always going to be, this value for t is always going to be positive, or it's going to be 0, which will make the whole thing 0, which is fine. But the value for that t is going to be positive, and then e to any power is always a positive number. So you know that this function is always positive. In fact, it's, this is greater than 0 for t greater than 0. So we don't need to worry about taking the absolute value of it. It's already always positive. So how many miles did she travel from 0 to 2? That's just the integral from 0 to 2 of t e to the 4 minus t squared. And how are we going to integrate t e to the 4 minus t squared? You're going to want to let u equal 4 minus t squared and have du be negative 2t dt. So I'm going to put in a negative 2 and a negative 1/2. And that's going to give me negative 1/2 of the integral. Now it's going to be from 4 minus 0 squared, which is 4. And then 4 minus 2 squared, which is 0. And then we'll get rid of the negative 2t dt, make that a du, and we'll have e to the u du. Everybody good with that? Okay. And then because I don't have to do this, but because my lower limit is larger than my upper limit, I can flip those and change the sign out in front. So I had a negative out in front, I can make that a positive now. And now the integral of e to the u is just e to the u, 0 to 4, which gives us 1/2 e to the 4th minus 1/2. And I guess that's the number of miles. So they gave you 3 points for that, 1 for setting up the integral correctly, 1 for getting the correct antiderivative, and 1 for the final answer. Good there on B or no? All right. No, that was A. Good on A. Good on A. Yeah. Part B. We want to know at t equals 3, is Chloe's speed increasing or decreasing? So how do we determine if speed is increasing or decreasing? We need to find the velocity at 3, and we also need to find the acceleration at 3. Okay? If they have the same sign, speed is increasing. If they have opposite signs, speed is decreasing. So v of 3 is 12 minus 9 minus 9, which ought to be negative 6. And then a of 3, we'll need to take the derivative of the v function, which will be -3 minus 2t. And we'll evaluate that at t equals 3. So that's -3 minus 6, that's -9. Both are negative. So therefore, speed is increasing because v of 3 and a of 3, either you could say have the same sign, or you could say are both negative or something. They gave you 2 points for that. One for showing both of them as negative, and one for an explanation. Good? All right, part C. We want to know, is there a time t between 0 and 4 at which Brandon's acceleration is equal to 2.5 miles per hour. So if his acceleration is 2.5 miles per hour, and this is a differentiable function, b, that means that b is continuous and differentiable, which means that the mean value theorem applies to this velocity function. So if the average rate of change of the velocity on any interval was 2.5, then the instantaneous rate of change of the velocity, which would be the acceleration, must be equal to 2.5 also. So if I look at these slopes here of all of these, 8 minus, we probably have to just show them all until we found one. 8 minus 1 over 1 equals 8, right? No, equals 7. I should probably subtract the 1. Equals 7. I can subtract. 1.5 minus 8 over 1. What's that? A weird negative number? I guess. Looks like it's negative 6.5. And then from 2 to 3, that's negative 5 minus 1.5. That's another negative 6.5. No, it's negative 5. Oh, why am I doing all these separately? It specifically says between 0 and 4, so we should do between 0 and 4. I guess, well, we'll keep doing what we're doing here. The next one, 11 minus negative 5 over 1 is 16. So on each of those separate intervals, it never was. But if we did the whole thing, I looked at the chart there, 11 minus 1 is 10 over 4 minus 0. That's 10 over 4, which is 2.5. Maybe I should have done that first. Oh, well. 2.5. So yes, by the MVT, there must be. What happened to the rest of my 2? Yes, by the MVT, because the function is continuous, the function is differentiable, and the average rate of change between 0 and 4 was 2.5. Now, if the average rate of change between 0 and 4 hadn't been 2.5, probably should have checked 0 to 4 first, the entire thing. But if that one still didn't work, you would want to check every other one. So 0 to 1, 1 to 2, 2 to 3, 3 to 4 to see if any of those work. Right? 0 to 2, 0 to 3. You'd want to check 1 to 3, 1 to 4, 2 to 4. You check every different possible interval to see if any of them came out to be 2.5. Because if any piece of it came out to be 2.5, then it must have happened on 2.5. Just so happens that 0 to 4 did. Does that make sense to everybody? Yeah? Just to make sure. Okay. Cool. That was worth 2 points. 1 point for getting the value and 1 point with your explanation that included continuous, differentiable, and MVT. Good? Oh, good. All right. Part D. is there a time between 0 and 2 in which Brandon's velocity is equal to Chloe's velocity? So we only know a couple selected values of his. So we know that at 0, his velocity was 1. So if we plug in 0 here, let's see if C of 0 equals 1. Well, C of 0 is 0 times e to the, what is it, e to the 4th. That does not equal 1. So not at that time. Next option would be C of 1. Does C of 1 equal 8? Well, C of 1 was well, there it is. I couldn't find it. 1 e to the 3rd. That does not equal 8. And if we look at 2, there we go. So we look at 2, what do we get here? 2e to the 0. So 2e to the 0 is 2. That does not equal 1.5. But what we still need to be able to do is we need to look in here and say that somewhere on this interval, so we're saying, is there a time when his velocity is equal to her velocity? So his velocity went from 1 to 8 to 1.5. True? So this is Brandon. He went from 0, what was it, 0, 1, no, 0, 0 to 1 e cubed to 2. And she went, no, I wrote those wrong. That was what she did, huh? She did that. And he went from 0, 1 to 1, 8 to 2, 1.5. And so if we're looking at all of those, she started at 0, he started at 1, he went up to 8, and she went to e cubed. So she's gone past 8 on that interval, and he has only gone up to 8. And so therefore, if she started below 1 and finished above 8, then she must have crossed his path at some point. Right? They must have been going the exact same velocity at some value on that. And we can note that here, I mean, she went from 0 to 2, and he went from 1 to 1.5. So again, they must have crossed those values again. So by the IVT, we could say that on 0, this is they said 0 to 2. On 0 to 2, Chloe went, Chloe hit, we say Chloe hit every value between 0 and 2. Brandon between 1 and 1.5, and therefore they must have crossed paths at some point in terms of velocity. And they gave you 2 points for that. Good? All right, any questions on that one? All right. Last one. First off, we want to show what the derivative of this function is. So we'll take the derivative implicitly, 4x plus 6y dy dx minus 4x dy dx, and then minus 4y equals 0. And then we'll solve for dy dx. No, implicitly, right, we took the derivative implicitly and used the product rule for the minus 4xy. So we've got 4x minus 4y. Do this where we have more room. We've got 4x minus 4y equals 4x minus 6y times dy dx. If I take the 4x and the 6y to the other side and factor out the dy dx. So we got 4x minus 4y over 4x minus 6y equals dy dx. That's not exactly like that. In fact, they've got the negative split. So if we multiply by negative a half and by negative a half here, that's going to give us a positive 2y minus the 2x over a positive 3y minus the 2x. So we can show that that is the derivative. That was worth 2 points. 1 point for correctly doing implicit differentiation, 1 point for simplifying it down to what they have. Good? Part B, find the slope of the line tangent to the curve at each point on the curve where x equals 6. So that means there may be multiple points where x equals 6. So we'll plug in 6 for x first. 6 squared is 36 times the 2 is 72. So 72 plus 3y squared minus 24y equals 36. Or 3y squared minus 24y plus 36 equals 0. Divide all those by 3 to make life a little bit easier. Y squared minus 8y plus 12. Factor to y minus 6 and y minus 2. And so the points are x equals 6, y equals 6, and x equals 6, y equals 2. And so we want to find the slope of the tangent line at each of those points. So we'll plug in dy dx at 6, 6. Well, looks like that should be what? I plug in 6 for x and 6 for y, what's the numerator going to be? Looks like 0. And the denominator is not 0, so that's 0. And dy dx at the point 6, comma 2, looks like that should be 4 minus 12 over 6 minus 12. And that's negative 8 over negative 6, which is cancel out the negative 8/6 is 4/3. And they gave you 2 points for that, 1 for each of those slopes. Good with part B there? Yep. All right, part C wants us to find the positive value at x at which the curve has a vertical tangent line. So if the tangent line is vertical, that means that the slope is, if the tangent line is vertical, the slope is undefined. Okay? If the slope is undefined, that means the denominator of the derivative needs to be 0. What happened there? So that was 3y minus 2x needs to equal 0. And what does it say? It wants us to find the positive x value. So let's figure out what y is. Y is then 2x over 3. So we want to know, for our original equation, when does y equal 2x over 3? So we'll go back in, we'll replace the y's with 2/3 x. So we're going to have 2x squared. What did I say? 2/3 x? that what I said? Yeah. So plus 4/9 x squared times 3. So that ought to be 4/3 x squared. And then minus 4xy, like we just said, y is 2/3 x, right? So that ought to be minus 8/3 x squared. Equals 36. Right? Yeah, equals 36. We got 2x squared minus 4/3 x squared minus 8/3 x squared. That's minus 12/3 x squared. That's minus a 4x squared. So we got 2x squared minus 4x squared is negative 2x squared equals 36. And we end up with a negative. Hopefully I didn't make a stupid mistake there. Curve has a vertical tangent line. Must have missed the sign. Oh, that's a plus 3y squared. That's where I missed the sign. That's a plus 4/3 x squared. I just missed the sign. Don't miss the sign. All right, 4/3. So we have 2x squared plus 4/3. So that's 10/3 minus 8/3. So we have 2/3 x squared here now. That's better. That gives us x squared equals 54. Or x equals, I think it's the positive value of x, so the square root of 54, or 3√6 if you want. And that was worth 2 points. 1 for setting this equal to 0, and 1 for this point. So even if you didn't know what to do once you got y equals 2/3 x, you could have at least got half the points for that problem still. Good or no? All right, last thing, part D. Now we're going to say that this function is a function of time. And at t equals 1, they give us all these values. Find dx dt. So we're going to take 2x squared. What was it? Plus 3y squared minus 4xy equals 36. And we're going to take the derivative of everything with respect to time. So we're going to get 4x dx dt plus 6y dy dt minus 4x dy dt using the product rule minus 4y dx dt equals 0. Goodbye, whoever left in the Zoom. And then we'll just plug in all the values. So at t equals 1, x is 2. So that's going to give us an 8 times our dx dt. We need a y value and a dy dt. I guess people just don't care about this anymore. This was still an 8. And we need to find our values. So let's see here. Our value of dx dt is what we're looking for. The value of dy dt is 4 and y is negative 2. We got negative 2 and we got 4. So negative 2 and a 4 and a 4 and a negative 2. Set it equal to 0 and solve for dx dt. So this is a 12 times a 4 is a 48 minus a 32 is 16. So we'll bring that to the other side as a negative 16. And then this is an 8 dx dt plus another 8 dx dt. So we have 16 dx dt. Hopefully I did all my arithmetic there right. Did I do all my arithmetic right? It doesn't look like it. Oh, no problem. Nice to see you. Those of you that aren't taking the June 9th test, you might as well just go. Let's see here. 4x dx dt plus 6y dy dt minus 4x dy dt plus minus 4y dx dt equals 0. Something I plugged in must not have been, I must have missed a sign again. Oh, I keep making this a negative. That's a positive. Making that a negative for some reason. All right, so now we've got a negative. This is still a 16. This side was a negative, what is that? Negative 48 minus 32, which is negative 80. This was a 16, as a negative 80, we bring it over as a positive 80, and you should get dx dt equals 80 over 16, which is 5. And that was worth 3 points. 1 point for doing the product rule here for this, 1 point for the whole derivative being correct, and 1 point for the final answer. 3 points. All right, that was fun. That's it.